human immunodeficiency virus, commonly known as HIV, is a virus that eventually leads to autoimmune deficiency syndrome or AIDS. HIV becomes AIDS when the number of CD4 cells, also known as helper T cells, fall below 200 cells per cubic milliliters of blood, when the normal level usually ranges from 500 to 1,500 T cells per cubic milliliter. HIV enters the bloodstream and is transmitted through bodily fluids. It is sexually transmitted and sometimes transmitted by intravenous drug use. HIV enters the body through bodily fluids. It is already skipping the first line of bodily defenses altogether. The first line of defense is the skin, mucous membranes, and stomach acid, which will block or kill any pathogen from ever infecting the host cells. The second line of defense is activated the inflammatory response, and HIV causes swelling in the groin.
Once HIV enters your body, it begins to target the CD4 cells. The outer envelope of the HIV is covered with glycoproteins, which mutate frequently. So the T cells won't be able to recognize the virus, killing it off because the viral DNA and the glycoproteins enter the cell. With the low CD4 count in your body, it can no longer fight off invaders. Also, with the low CD4 count, your B cells won't be able to be activated, and as a result, memory and effector cells won't be able to be produced. When the HIV enters, it alters the DNA of the cell itself. And the immune system, as a result, shuts down. In normal conditions, the binding of the T cell to the MHC2 complex releases cytokines that alert the immune system of an invasion. But however, when HIV infects, cytokines are not produced, so your body's alarm system stops working. Your body does not know it's being attacked. So the body is unable to kill the virus because it's unaware that it's even there. But there are ways to slow it down. A series of drugs used to treat HIV are called antiretroviral therapy, or ART. ART slows down the rate of HIV replication by releasing transcriptase inhibitors. Another possible cure is to get a bone marrow transplant to replenish the B and T cells, but there's no complete cure as of now.